Hello everyone, my name is Meghana from the Hades team. Our robotics project aims to solve the problem of multi-control gesture recognition using a mobile robotic arm. This technology allows us to control a robotic arm using hand gestures. The robotic arm has a wide range of applications, including manufacturing settings where it can automate assembly tasks and healthcare settings where it can assist with patient care. Additionally, the robotic arm has basic applications such as assistive technology for people with disabilities or low mobility to perform daily activities like feeding themselves, turning pages in a book, or etc. To construct the robotic arm, we started by building a base called a rover on which our arm can be placed, which is made up of several components that allow it to move. Our base or the rover is a 6WD1a robotic kit, which includes a picksock, which is an autopilot system that controls the flight of the unmanned aerial vehicle, which is UAVs. In our case, it's the rover. And next comes the motor controller. We used a Sabertooth 2x32 motor controller, which controls the speed and throttle and steering of the wheels by connecting it to the DC motors of the wheels. And next comes the telemetry radio, which transmits the data between the UAV and the ground control station. And then the GPS provides the location data, which is very crucial for autonomous navigation and waypoint following. And then we made our rover installed as a firmware into a platform called Mission Planner, through which we can simulate our rover by giving different commands. After connecting the components and battery, we wrote the code that is independent of the GPS and dependent of the GPS. In the non-GPS code, we use channels.override function, which defines the channel numbers through which we can change the steering and throttle. In the GPS code, we use location global relative function, which takes the latitude, longitude, and altitude as the parameters and move to a particular location by use of the simple goto function. Here is a small clip of the rover. And next comes the most important and powerful component of our rover. It's the Jetson Nano. The Jetson Nano is a small but powerful computer we use for image processing, machine learning, and other advanced computations. It processes image data captured by the UAV's cameras and sensors and performs a real-life object recognition. We installed ROS and Mavros on the Jetson Nano. We all know what is ROS. It's Robot Operating System. We utilized ROS as a framework for integrating sensors, processing data, and controlling the robotics arm movement based on the gestures detected. Mavros. Mavros provides a communication interface between ROS-based system and a Mavlink-based autopilot that controls the UAV carrying the robotic arm. And now, the 6DOF robotic arm, which has 6 degrees of freedoms, which means 6 servo motors, which is capable of performing tasks such as picking and placing objects in a manufacturing or assembly line and welding, cutting, or polishing materials. The implementation of the robotic arm involves a camera that captures the user's hand movements and records them as a video stream. This video stream is then processed by a computer vision algorithm that analyzes the images and recognizes the gestures made by the user's hand. The robotic arm is designed to manipulate the objects based on the user's hand movements and can be controlled using software that translates the gestures into commands that moves the arm in a specific way. In summary, our system captures the hand movements using a camera, analyzes the images using computer vision algorithm, and translates the hand gestures into commands that control the robotic arm. This allows the user to control the arm naturally and intuitively without the need of the physical controls or complex programming. Thank you.